An industrial company claims that the pH level of the water in a nearby river is 6.8. This is the claim. Claim. Is. What does is mean? Equal. The mean is 6.8. Is this my HO or HA? Because it has an equal sign, right? HA has no equal sign. Not equal to. What tail test am I? Two-tail test. Some things just don't change. This is my reject H0, reject H0, and fail to reject H0. Okay? Now, we keep going. You randomly select 39, here comes your sample information, 39 water samples, and you measure the pH of each. The mean sample and the mean and the sample standard deviation are 6.7 and 0.35 respectively. Is there enough evidence to reject the company's claim at a level of significance of 0.05? Well, reject means that's an HO. I check to see, yes, I'm an HO. Okay, now, because this is a t-score, we can't find a p-value unless we use your calculator. So if you just take a look at this, we're just going to go through using your rejection region on this, and then we're going to put it on the calculator and test your p-value. So we're going to find your z-score, but because this is a t, because we do not know the population standard deviation, we instead use a t-test. That's the only difference between your z and your t, is that we use a t. It actually looks the exact same. We're going to find our cutoffs in a minute. It looks almost the exact same, except it uses a sample standard deviation. Now, and the only other difference is finding your cutoff. You have to find it off your table 5 instead of your table 4, right? Everything else is pretty much going the same. So I have my table 5, which is on A18. You have 2 tails. It already does this for you. 2 tails, and your level of significance is 0.05. What's your degrees of freedom? What's the degrees of freedom for this guy? When n is 39, 38. So follow your 2 tails, follow your 0.05, come down to 38, give me your cutoff point.
2.0.
Good. So I know my curve is symmetric, so 1 is positive.
That was 2.0.
Oh, wait, sorry. Thank you, Dan. Okay, there's my cutoff. This is my critical value. Before we had a Z critical value, we just have a T critical value. We use your chart. We don't have to worry about dividing anything in half. It has a 1 tail. It has a 2 tail. So we go right to that, degrees of freedom, and we find it. Okay? Now, we plug in your information just like we did before. It almost looks like the z-score except for the sample versus the population, and you don't even really notice that. Plug in everything the way it is. Use your n, not your degrees of freedom, and you're going to find your t. So they find their t to be negative 1.784. And again, we come over and we see where it falls. Don't forget the zeros in the middle. So 1.784 would fall in here. So what's our decision? Fail to reject what? Makes a difference what you fail to reject. We fail to reject the HO. So again, we go back to the HO. If we fail to reject it, that means we agree with it. We like it. But we can't say that. We go to your chart. We follow your claim is HO. We fail to reject HO. So we interpret this as there is not enough evidence or insufficient evidence to reject the claim that the mean pH of the water is 6.8. Okay? We're saying there's not enough evidence to reject it. That's how we have to say we like it. Okay? Are we good with this? Okay, let's take a look at this, guys. The mean, same setup. The mean is 1890 milligrams per liter. This is our claim. This is our HO. Again, two-tailed test. Now, even though we draw this big enough, you know that that area is really small because it's half of 0.01. We're taking half of this. So isn't that really, really small? So it's very, very tiny at the end. Very tiny, but we have to make it large enough so that we can at least look to see what fits in there. So we've got two reject regions, HO, and we've got to fail to reject HO. Okay, and we need your cutoff points. Now, two ways. You could do inverse T, cut it in half, and do degrees of freedom, or you can go to your table, which I find the table easier, because it gives you a one-tailed, two-tailed. Some of you forget to divide by 2. With the table, you won't forget to divide by 2. So what's your cutoff value here? 2.71. This guy is positive 2.71. Should have one more decimal, but that's all right. Now, well, the T is a little different, but that's okay. We do your test statistic. Standard deviation from the sample. So we didn't pull this out. We sampled 39. We had a sample mean of 2350 and a standard deviation of 900. Even though it looks like it's far apart, look at how high your standard deviation is. And what'd you get for your T? 3.19. That's pretty extreme in itself, isn't it? Didn't we say plus or minus 3 is very unusual? That's pretty extreme in itself. So we come here and we say, oh, 3.919 falls in your reject HO. That means I come back here, I don't like this. I'll have to go with my alternative. It is not equal to 1890 milligrams per liter. Okay? And follow your chart. Your claim is your HO. You failed to, you rejected HO. Sorry, you rejected HO. So you're going to say there's enough evidence to reject the claim that the conductivity is 1890 for your river. You don't say the other one works better, this is good, this is bad. You have to follow that chart. Good? See.